Welcome back to Pipro vs. YouTube channel where curiosity meets the code. Today our topic of discussion will be some of the NLP algorithms. So let's get started. Firstly, we are having the contents. I'll give you an introduction to what is NLP, then we'll talk about tokenization, then stemming, part of speech tagging, speech recognition, named entity recognition, which is NER. Then, what is NLP? NLP is all about giving computers the ability to process and understand human language in all its complexity. It's not just about recognizing words, but about grasping the meaning behind them, the nuisance of grammar, and the subtle clues that shape our communication. So, NLP aims to replicate this remarkable feat, enabling computers to perform various tasks like understanding the sentiment of tweet, which is whether it's expressing joy, anger, or sarcasm. Then we have translating a website from English to Spanish, which is capturing the meaning and nuisance of the original text. Then we have building a chatbot that can hold a conversation, that is responding to questions, providing information, and even engaging in small talk. And we have analyzing medical records, which is extracting key information to support diagnosis and treatment. Then we have summarization, a lengthy article, which is considering the main points for efficient reading. So, what are some of the impacts of NLP is already transforming our life, such as search engines, understanding your queries even when you don't use perfect grammar, or your personalized assistants like Siri, Alexa, and Google Assistant responding to your natural language comments. We have voice to text technology, which is dictating emails and documentation with surprising accuracy. Then we have machine translation, which is breaking down language barriers and forecasting global communication. And we have fraud detection, which is analyzing text for suspicious pattern and protecting online transactions. So some of the major algorithms of NLP include tokenization, stemming, part of speech tagging, speech recognition, and we have named entity recognition, which is NER. So what is tokenization? Again, it's a word level tokenization. This is the simplest approach, splitting text into individual words based on white space or punctuations. Then the efficient and easy to implement but ignores compound words and context. Secondly, we have character level tokenization, which splits text into individual characters, providing granularity for tasks like spelling correction and morphological analysis. Then we have can be computational, expensive, and lead to data sparsity. The thirdly, we have subword level tokenization, which handles out of vocabulary, which is OOV words efficiently by breaking them down into smaller meaningful units like prefixes, suffixes, or morphemes. Then we have popular algorithms, which include byte pair encoding, which is BPE. This learns the most frequent character pairs and merges them into new tokens, iterating increasingly vocabulary size. Then we have word piece, which is similar to BPE but considered word boundaries and morphologic, leading to more linguistically aware tokens. Then we have sentence piece, which is a neural network based approach that optimizes subword units for efficient language representation. Next, we have stemming. So, what is stemming? Stemming is a technique in natural language processes, that is NLP, that aims to simplify words by removing suffixes and prefixes, reducing their to their stem or base form. Imagine it like for pruning a tree or removing the leaves and branches to reveal the main trunk. This helps group similar words together for tasks like the information retrieval. In this, finding the document relevant to the search query even if the extract word isn't present. Then we have machine translation, which is matching words between the languages despite morphological differences. Then we have text cluttering, which is grouping documents based on thematic similarities. Next, we have some of the popular stemming algorithms, which is Porter stemmer, one of the most widely used algorithm. It removes common suffixes like ing, s, li, and applies specific rules to handle irregular words. Then we have Lancaster stemmer, which is similar to Porter but more aggressive in removing the suffixes, potential leading to overstemming. Example: playing or becoming play. Then we have snowball stemmer, a family of language-specific stemmers offering greater flexibility and accuracy. Some of the challenges and consideration here in stemming is overstemming, removing too much information leading to ambiguity, example running and dancer stemming to run. Then we have understemming, which is failing to remove relevant suffixes, reducing the effectiveness of grouping and retrieval. We have language specificity, that is, stemming algorithms might not work well for all languages due to morphological differences. Next, we have part of speech tagging, which is in a capitative world of NLP, part of speech, which is POS. Tagging algorithms act like linguistic detectives, unraveling the grammatical identities of word within a sentence, which imagine labeling each word as a noun, verb, adjective, adverb, and so on, revealing the intricate dance of a grammar that gives meaning to language. Here's how POC tagging algorithm works. Their magic. The first one is rule-based approaches. These rely on handcrafted rules and linguistic knowledge to assign tags based on word morphology, context, and syntax syntactic patterns, and they are fast and interpretable but require significant manual efforts and might struggle with ambiguity or expectation, which so the most common example being Brill-Steiger and TNT. You can just Google these two words, you will get the information of how this works. Secondly, we have statistical approaches. These leverages statistical models, hidden Markov models, which is HMMs, or conditional random field, which is CRFs, to predict the most likely tag sequence for a given sentences, and they are often more accurate than rule-based methods, especially for larger data sets and languages with complex grammar. Then examples here include Viterbi algorithm and bidirectional LSTMs. And then we have machine learning approaches. These employ classifiers like support vector machines, which is SVMs, or neural network, which is NNNs, to learn POS tagging from labeled data. And they offer high accuracy and flexibility adapting to specific domain and languages. Examples include perceptrons and transforms based models. Then some of the challenges and consideration in part of speech tagging includes tag ambiguity, which is some words have multiple possible POS tags depending on context. Example, book can be a noun or a verb. Then we have data sparsity. Rare words might pose challenges for statistical and ML models. Then we have language complexity, which is algorithms need to be adopted to handle the unique characteristics of different languages. Some of the next algorithms include speech recognition. Speech recognition is a technology that converts spoken language into text. It is used in a variety of applications such as virtual assistants such as Siri and Alexa and Google Assistants all use speech recognition to understand your spoken commands. Then we have dictation, which is speech recognition can be used to dictate text from emails, documents, and more. And we have automatic captioning, which is speech recognition can be used to automatically caption videos and live streams. Then we have language learning, which is speech recognition can be used to help people learn new languages by comparing their spoken pronunciation to a native speaker. Then we have accessibilities, which is speech recognition can be used to help people with disabilities who have difficult typing or using a mouse. So there are two major types of speech recognition algorithms. First one is acoustic models, then we have language models. So for acoustic models, these models are trained on a large corpus of spoken language and learn to associate sounds with words. Then we have the language models. These models are trained on a large corpus of text and learn the probabilities of word occurring together. Then we have speech recognition, which is a complex task, and accuracy of speech recognizing algorithms can vary depending on number of factors such as quality of the audio and background noise and speaker's accent. Then we have the named entity recognition, which is NER. So NER is a subfield of natural language processing, which is NLP, that aims to identify and classify named entities mentioned within a text. These entities can be Firstly, people, which is Barack Obama, etc. Locations, some of the places that we have. Organizations, some of the organization dates and time. Then quantities, like it can be in liter, kilometers, or dollars, rupees, etc. And other categories, which includes brand, product, diseases, etc. So NER algorithms are pretty typically involved in two main stages. First one is identification, second one is classification. For identification, we have detecting named entity mentioned within the text. This often involves techniques like tokenization, part of speech tagging, and Geistier lookups, which is matching against a list of known entities. Secondly, we use it for classification, which is assigning a category label to each detected entity, which is this is typically involves machine learning models trained on large data sets of annotated text. Next, some of the specific NER algorithms used to particularly application depends on factors like desired accuracy, efficiency, and the domain context. Some of the popular NER algorithms include hidden Markovers models, which is HMMS, which is statistical model and the sequence of the words and the entities within the text, and we have conditional random fields, which is CRFs, which is take into account contextual features and relationship between the words and entities. Then we have neural networks and ends, which is learn complex patterns from large data sets and achieve high accuracy for various NER tasks. Next, we have some of the fundamental tasks. Firstly, being lexical analysis, which is breaking down the words. Firstly, we have tokenization. The first step is to chop up the text into meaningful units like words, punctuation marks, and even emojis. This creates a basic building blocks for further analysis. Then we have stemming, which is image trimming and the branches of a word, which is stemming removes suffix and prefix, reducing words to their base. Example, playing becomes play. Then we have limmatization, which is similar to stemming, but limmatization takes context to account and chooses the most appropriated base form, that is studies becomes study instead of stud. Then secondly, we have systematic syntactic analysis, which is understanding the sentence structure. Firstly, we have parsing. This is like a diagramming a sentence, revealing how words are grammatically related and arranged. Imagine identifying the subject, verb, object, and their connection. Then we have part of speech tagging, which is assigning labels to each words based on grammatical function, which example noun, verb, adjective. This helps understand the role of each word in the sentence. Then we have dependency, which parsing, which is going beyond simple labeling. Dependency parsing, identifying the specific relationship between the word, revealing the deeper structure of the sentences. It's like mapping the network of connections between the words. So thirdly, we have semantic analysis, which is diving into the meaning. We have word sense disambiguation, which is many words have multiple meanings. Example, bank is a financial institution or a edge of the river. Then we have task analyzer context to determine the intended meaning of each cases. Then we have named entity recognition, which is identifying and classifying named entities like people, places, organization. Example, John Smith is a person in Paris, is a city, and Microsoft is a organization. So that's it for today. If you have learned something from this video, please do like, share, and subscribe to our channel. Thank you.